Question 3. The instruction is simply to factorize the following, and we will jump straight into question 3.1, which is a squared minus 6a minus 16. So this is a basic straightforward trinomial. I've got three terms here: a squared minus 6a minus 16. So I know this is a trinomial. I can see immediately that there is not a common factor. However, quite a few of you, those of course that are in my class, you try to take out a highest common factor, and if you do that, of course the only common factor that you would be able to find between these three terms is the number 1, because each one of them, you can effectively say that you can sort of take out a 1 from each term. But if you take out a 1, then you would effectively end up with the exact same thing, which is actually what a lot of you did. So this is, for some reason, a common mistake made by grade 9 learners, even grade 10 and 11s. So first of all, maybe that comes from the fact that you've been taught, and you know that the very first thing you need to do when you factorize to check if there's a highest common factor, and then after that you would go on to difference of the squares and the trinomial, dependent on the form, of course, and of course we have the grouping. Now this, if you try to take a highest common factor, like I said, you can only take out 1, which doesn't count. Okay, so there's nothing common between these three terms except for 1. And if I take out the 1, then I would effectively end up back where I start, because 1 times the bracket, you can just take away the 1, because you don't write the 1 in algebra, and you would be effectively left with the same thing, which is of course not what is required. That is not how you factorize this particular expression. So let's just clear this and see what we were supposed to do. So we were supposed to recognize that, you know what, I cannot take out the highest common factor apart from 1, so 1 doesn't count. So is it dots? Is it the difference of two squares? No, because there are more than 2 terms first of all, and that immediately cancels it out. Difference of 2 squares, of course, is emphasis on the 2 squares. Okay, and this of course is not that. Is it a trinomial? Well, there are 3 terms and it has the right form, so yeah, we could probably go with that one. Grouping, of course it's not, because grouping is specifically for 4 terms. Actually, I mean, that's a good way to remember it, because it's always the 4th one on the list. It is reserved for 4 terms or more sometimes. So this is of course not 4 terms, so it must be a trinomial. So if we've identified that this is a trinomial, we can see that the coefficient of the square variable is 1. We'll get into more complex trinomials such as these, where the coefficient of the a squared or x squared is not 1, but it's actually like 5 or 17 or 18, whatever, very large number. We will get into that stuff soon, but for now we know this from grade 9. We know that we can open up 2 brackets and we can factorize the first term, so a and a. Ooh, where did the other a go? That's a and a. And then we need to factorize the last term, which is 16. And of course, I'm not going to cover the various methods in this video, but I mean, I know that you guys have these table methods that you use to write out the factors and I don't know, all kinds of other stuff. I'm not going to cover those in this particular video. However, we might look at that when we look at more complex trinomials. But for now, I think with relatively small numbers like 16 and 9 and whatever, any numbers that are relatively low, you're supposed to know your times tables enough to sort of break down this number into its factors without having to draw all kinds of elaborate tables. But if that is what helps you, then of course go ahead and do that. But if I look at the factor pairs of 16, then I know I have 1 and 16, I have 2 and 8, I have 4 and 4, and I think that's about it. Of course you can swap around the 8 and 2, just in case you of course need to place them differently according to your trinomial. And of course, looking at this trinomial, we can see that our last term is negative. So if our last term is negative, we know, and this is just according to all these little shortcuts that we were taught in the past year or two, if my third term is negative and I'm sitting with a basic trinomial where the coefficient is a 1, then I know that my signs are going to be different. I also know that, well, if I look at my third term, my middle term rather, I need to choose a factor pair that is, going to end up adding up to the middle term. Now I can see clearly that, of course, 16 and 1, that will not do. 2 and 8 looks like we can add that up somehow to a 6 or negative 6. 4 and 4, of course, will not do. So it's going to be between these two, right? It's just about placing them properly. So I need to add up to negative 6. So when the third term is negative, I was pointing to this third term for a reason. The third term is negative, so I know that the bigger factor. Now, what do I mean by that? With these factor pairs, so the reason why I don't really need to write this down twice is because I can just use the first set or pair, and I know if my third term is negative, then the bigger factor, which is 8, will go with that negative sign. And then, of course, that will mean that the 2 belongs here. So if I had to test this, this will give me plus 2a, and that will give me negative 8a. And if I add these two together, positive 2 plus negative 8 or minus 8 will give me negative 6a. So that checks out. That gives me the third term. And that means I'm done. Those are my factors, a plus 2, a minus 8. Now, this explanation was a bit long, but I hope that you understand that I wanted to go into as much detail around the thinking when it comes to choosing the factor pairs for the third term, because it's all about the third term's factors and how it will then help you to add up to the middle term. Okay, so like I said, there are other methods, there are tables and all this kind of stuff. This is just the quickest way that I could try and explain this to you. So it's all about choosing factor pairs and then choosing the pair that works. Also, it's good to know that there are certain things that you need to apply, certain rules that you need to apply based on the sign of the third term. So if the third term sign was positive, then that again gives you a set of different rules. If the third term is positive, you will find that both signs in the brackets will be the same. Either it's going to be minus and minus or plus and plus. But if the third term is negative, you know that one bracket will be positive and one will be negative, and it doesn't matter which one you choose. You could have made this one the positive one and that the negative one. Then it just means that the 8 would have been in this bracket and the 2 would have been in this bracket. So I hope that helps.